Now let's talk about mutable sequences. Mutable sequences differ from their immutable sisters in that they can be changed after creation. There are two mutable sequence types in Python: list and byte arrays. Let's start with list. Lists, Python lists are mutable sequences. They are very similar to tuple, but they don't have the restriction of immutability. Lists are commonly used to storing collections of homogeneous objects, but there is nothing preventing you from store heterogeneous collection as well. Lists can be created in many different ways. Let's see an example. For example, I could say, first of all, I need to say lists. Okay. Then I'll create a list like 1, 2, 3. You can add some any object. For example, 13. And also you can say count in order to count any specific items. In this case, 1, which is 1 time. You can say a dot extend uh, 5, 7. You'll print 8 and you will see that it was added to the original list. You can say 8 dot index, I don't know, index of 13. Well, it's the third index, okay. Another way to say insert dot 0 and 17. If you print A, you will see that 17 was added in the first position in the 0 index, okay. And also you can say a.pop. It will return 7. And also you can say pop, and you can specify a parameter, a position, an index position, and will return the corresponding position, okay. If you print A, you will see the 3 and 7 aren't in the list anymore. But you can be more specific, saying remove the item 17, remove, print A, and it's 17 isn't in the list anymore. A dot reverse, print A, A dot sort, print A, in order to sort the list. And also you can remove all the elements from the list with a dot clear, okay. A is empty. Another interesting way to create a list is something like this. You can create it with a string. A list, you can say hello. You will print A, and you will see an array on items, on characters, which represent a character of the word hello. You can say a dot append, and you can add any type of variable, and you print A, and you will see hello, and the last one is a number variable. Then you can say a extend, and you can extend a tuple like this to 3. You will print A, and you will see 1, 2, 3 at the final, at the end of the list. And also you can say extend and you're extending an string. In addition to this, if you got an array of numbers, probably you need to operate them. For example, you need the mean value, or you need the max value, or you need to sum them. Probably you need a length. Perhaps you have got an additional list 5, 6, 7, 8, 9, like this. What about if we say A plus B? Well, in the, plus in this case means a concatenation, okay? Well, the same way, if you say A 2 times, it duplicates a value, okay? Well, now let's talk about mapping type in dictionaries. Of all the built-in Python data types, the dictionary is easily the most interesting one. It's the only standard mapping type, and it's the backbone of every Python object. A dictionary maps keys to values. Keys need to be hashable objects, while values can be of any arbitrary type. Dictionaries are mutable objects. There are quite a few different ways to create a dictionary. So let me give you a simple example of how to create a dictionary. The same dictionary, for example, I want to create first of all dictionaries. I want to create A and C, okay, in different ways. The first way, A tick A1, C -1. Another way is to say B, not B, B, A, Z. In another way is you can say dig, zip, A, Z, 1 -1. Another way to create is saying dig, dict, perhaps like this. A, 1, Z, -1. Another way to create them is say E ticked C -1, A 1. If we test them, A, B equal to C equal to D equal to E, it might return true. They are similar, they are the same, indeed. Well, let's have fun with dictionaries. You can say, for example, D equal an empty dictionary, Okay. What's wrong? Nice. Okay. G equal A equal 1, 2. You can print D. You can say length of D. You can also print unspecific items, for example A, which have the value 1. You can delete or remove some elements from the dictionary. For example, I wanna remove B. Now let's print D and just return the A key and the 1 value. And also you can add an extra item, C equals 3. You can say C in D, which is true. You can also say 3, asking for the value, and I will return false, because you are asking for keys, where our keys are by the way is A and C. Okay. And also you can say clear in order to remove the whole dictionary. Another easy way to create a dictionary is you can say, for example, G equal to dict, and you can use the method zip in order to associate an string with iterable numbers like range 5. Oops, what's wrong here? Let's try again. Dict zip hello and range, and you will see the return. Okay, you have 80E1L101. You need the keys. You have them values. You have them the items. You've got them. Probably you need to know if a value, for example 3, in the values. Okay, I return true. Or you can test in a different way. For example, you can say E1 in the items, right? True. Yeah. E1 in the items. If you want to remove some item, for example, perhaps you want to remove a random item, you can use the method pop item. In this case, remove O. Now you have got this. Or you want to remove a specific item, for example, I don't know, L. L has gone. Or perhaps you wanna get H value. You've got 0. Okay? E1. Perhaps you wanna obtain an item. If it doesn't exist, you can say a default value. For example, we don't have 8 here. You can say 1,000, and I return 1,000 because A is not in our dictionary. Okay. Let's see our dictionary now. Well, it's D. What about if we wanna get an item that doesn't exist, a key that doesn't exist, for example, ABC? Well, it returns none. All these methods are quite simple to understand, but it's worth talking about that none for a moment. Every function in Python returns none unless the return statement is explicitly used to return something else. But we'll see this when we explore functions. None is frequently used to represent the absence of value, and it's quite commonly used as a default value for arguments in functions declarations.